Hello friends, welcome back to my YouTube channel. Today we are going to discuss about how the big company using data warehouse infrastructure and how they are switching from the Hive to the S3 bucket. Then they are moving to the Iceberg principle, and how Iceberg used to optimize the cost of data warehouse infrastructure. So friends, several major company leverage the features of Iceberg for data warehouse management, like Netflix, Airbnb, and if we are talk about Airbnb, where petabytes of data flow in a day. So how they are doing the cost saving and using the infrastructure and properties of icebergs and a spark. So we just move forward. So first we are talking about the data warehouse infrastructure at Airbnb and how they migrated from HDFS cluster to the S3. So as we all know, S3 is the cheap and we just pay as we go, and it's a high available and scalable storage. So Airbnb data warehouse storage was migrated from legacy HDFS cluster to S3 to provide better stability and scalability. S3 offer pay as you go pricing and high availability and scalability. HDFS provide right consistency guarantee, and S3 provides eventual consistency. So the company they were using earlier HDFS with Hive. Now when the S3 come to the picture, so what they do, they migrated the data from HDFS to the S3. So HDFS is good for write consistency, means when you write the data on the HDFS, so it immediately visible to the user. Suppose you upload the file, upload the data, upload the image, any kind of object into the HDFS, so it write consistency is a strong. So whenever user want to see, just upload the data and able to see instantly. But in case of S3, it provide the eventually consistency. It means when the user upload the data and suppose videos and any image, any object, so it would take little time, and the someone who just want to see the data, so it take minute in milliseconds time. So that's why we are saying that it's eventually consistency. So for strong write consistency, what the company doing, so by using the Hive, and they uploaded all the data into the HDFS, and after writing the HDFS they moved the data to the S3. So this is a kind of migration. So let's see how the Airbnb use further upgradation. And now the Hive challenges come itself. So first they replace HDFS with the S3, because S3 is a cheap, scalable and highly available and highly durable. So now we are talking about the computation engine. So we have the Hive and Spark. So they also migrated from Hive to the Spark and Iceberg principle. So what's the challenge they are facing when using the Hive? So Hive basically, the partition is stored as a physical directory structure, and their metadata is managed in the Hive meta store. So what happened in the Hive? So in the Hive, suppose we have the partition by the year and month. Suppose like the year partition. So the problem is that when the partition created on the Hive, it store all the data into the metadata, right? And in meta store. So when we are fetching the detail of the partition, first we need to fetch the detail of all the partition, list down all the partition using the meta store, and after list down the partition, then we will fetch the data. So there is a lot of time used to fetch the partition details. So Hive table are partitioned by fixed column, and partition column can't be easily changed, and changing a partition key, it can require rewriting large amount of data. So Hive table your partition by fixed column. So when we are doing the repartition on the Hive table, so it would take some time because we need to rewrite all the data. We need to create a new table and upload all the data into the new table. So that would take the time. So it's a little, challenging job to repartition the Hive table. And also the when there is a lot of partition in the Hive, suppose there is 1,000 of partition in the Hive table. So what it make query very slow. Why? Because first they read all the partition path from the Hive meta store, then it would fetch the data. So Hive is a challenging when there is a lot of partitions, when your partition key might be changed in the future, when you need to repartition the table. So the company faces challenges when they have the terabytes of data, like big company Airbnb and Netflix kind LinkedIn. So that's a challenging. So now the overcome this challenge. So what need to do? So there is a two things using in the data warehouse infrastructure, and that is like AQE, adaptive query execution in Spark. Second one is Apache Iceberg. So they both run with the use of the Spark. Adaptive query execution. So adaptive query execution solve the problem by adjusting the execution plan dynamically as the query progress. This allows Spark to optimize resource usage, reduce runtime, and improve performance. So AQE is something like it dynamically handle all the resource uses, all the partitioning strategy. You don't need to see the data skew. Don't need to worry about more about the data skew part, and you don't need to worry about the partition which is unnecessary. So all this AQE handle automatically. So it's a kind of configuration which we set in when we declare the Spark session, and at the time of that we give we set as the configuration of AQE. So it dynamically handle the resource management, and due to that we don't need to fully scan the partition. It make query fast. It optimize the query. It optimize the size of each partitions. So AQ is really helpful to for the performance optimization point of view. And second thing is Apache Iceberg. So Apache Iceberg is a table format delivered to deliver high performance read for huge analytics table. So Apache Iceberg is just something which make the data warehouse, data management little fast, and it's a something you can kind of we don't need to rewrite the data. We have the data on the single place where we have the all the version controlling. We can see history of the data at the same place. We don't need to worry about the history, and don't need to apply the ETL and rewrite the data into some other bucket, other folder. So at the same place all the history maintained. At the same place we can we have the consistent data, and that is a fast, because here there is a no such partitions folder or directory created. All these partitions and schema history stored in the metadata file, which managed by the Iceberg itself. So we don't need to manage the partition physical structure. We create the partition, but that all thing internally handled by the Iceberg. So when we compare with the Hive, so Hive is just creating the physical directory for each partition, but in Iceberg it is not like that. We just give the folder name, and inside that, suppose inside that years and month, all that partition directory structures and history, all these things managed by Iceberg itself. So when we query the data, it's not need to scan all the directory path first and then read the data. It can all handle by the Iceberg. So it make the performance very fast, and for huge analytic data warehouse the company using this Apache Iceberg with Spark. So Iceberg store support schema evolution without requiring the data. So what does mean by schema evolution? So schema evolution, it means that have Iceberg support schema evolution. It means we can update, delete, insert all the data on the top of the file. So suppose Iceberg table pointed to the file into the S3 bucket, and we want to update, insert, and we also want to change that structure of the table. So we can easily use insert, update, delete, alter command on the top of the file using Iceberg. So Iceberg support the schema evolution. We can change schema, we can add append the schema. So Iceberg also store partition schema metadata file in optimized file. So it's not create the physical structure. As I said earlier, time travel is a powerful feature for auditing. Time travel means we can see the previous history of the data. So if any update, deletion we did in the past, so it create the timestamp ID and snapshot ID into the metadata table of the Iceberg, and we can fetch the detail. Suppose if we are using the Athena and glue and spark, so on the Athena it create the metadata table we can see. And I also created the video on this time travel with spark and all this thing. You can watch that video, I will provide the link on that. So for now, time travel is something which can see the data of the previous time. So due to its optimized metadata management, flexible partitioning, columnar storage, Iceberg enable faster queries. So the company using this Apache Iceberg, and how it affect the cost and performance. So 50% reduction in the compute cost, moving from Hive to Spark plus Iceberg significantly reduce resource consumption, and 40% reduction in the job times, faster ingestion and querying due to the Spark optimization and Iceberg metadata driven architecture. Apache Iceberg is optimized for petabyte scale data processing in distributed environment like cloud storage like AWS S3. So that is a huge reduce the cost and also give the faster performance. So that it's about the Apache Iceberg. So yeah, now company using this Apache Iceberg and with Spark is very vastly. And I also created on the video on the Iceberg with the Spark. You can watch that video and you can clear all the concept on that. So I think this video you feel is good, and if you have any doubt, please comment and like my channel, subscribe the channel, forward this video to your friends. Thank you for watching it. Have a nice day.